All right, so we are basically in this topic of forces. There are two things we have to take a look at. One is your Hooke's law, and then we have to take a look at pressure in liquids, right? So today we'll take a look at Hooke's law, and in the next class we'll go over pressure in liquids. So when we talk about Hooke's law, we have to talk about what are elastic substances. So when we talk about what are elastic substances, so an elastic material is a material that can undergo deformation and return back to original shape and size. What? What? जो लाल रंग है क्या? So whenever we talk about an elastic material, right? So that is what an elastic material is. Now, we can go ahead and we can make a graph over here. Okay. So our graph will come something like this. Let's imagine that we have a spring, okay? Because a spring is an easy elastic material to imagine. We have a spring. Now, to that spring, I am applying a force, okay? That force will be in newtons. And when I will apply the force, the spring will undergo extension, right? It will extend. It will either extend or compress, right? Whatever happens, it will either extend or it will compress. So for example, if we have a spring, so this is the original length, right? This is the length of the spring. And then when we take the spring and we attach, let's say, a weight to it. So this spring is going to extend, right? It's going to extend. So our L1 minus L2, or I should say L2 minus L1, is going to be our extension. You can write down extension with either E or X. So if you draw the graph, you will see a relationship that looks something like this. Okay, so you are going to see initially that force and extension are directly proportional to each other. This is something that is explained by Hooke's law. Hooke's law states that force and extension will be directly proportional to each other will be directly proportional to each other until the limit of proportionality. right? So when we talk about, so up till the limit of proportionality, this is the limit of proportionality. So limit of proportionality is that point up till which force and extension will be directly proportional to each other. This we can relate using a formula. F is equals to K E, where F is the force in Newton. E is of course your extension in meters. And K is your spring constant. So spring constant is in Newton per meter. Spring constant will be different for different springs. Okay. So spring constant is sort of the material of the spring itself. Like whatever the material of spring is, it depends upon that. Okay. So your spring constant is dependent on the material. So whenever you have the same material, the spring constant will be the same. So like if the spring is the same, the spring is made of the same material, then you know that the spring is also going to be the same. Then when we, so this is your spring constant. So this is your limit of proportionality, basically. Okay. Then when we talk about limit of proportionality, so sometimes students have a small confusion. Okay. They think that the limit of proportionality is the point after which a student, or after which, the elasticity ends. That's what students often believe, that it is the point that where the elasticity basically ends. Okay. But that's not true. It's not the point where the elasticity ends. It is simply the point where the force and proportional will no longer be, force and extension will no longer be directly proportional to each other. Okay, that's all that it means, that the force and extension will just be no longer directly proportional to each other. That's all that it means. So it doesn't mean that you are going to lose the elasticity. The material will still behave in an elastic manner. It is just that the force and the extension will no longer be directly proportional to each other. So when you stretch the spring, it will still go back to original shape and size. It's just that you will lose the proportionality. Now, after the limit of proportionality, you get another point. This point is the elastic limit. Okay. Elastic limit is that point. Elastic limit is the point after which you will get the permanent deformation. Right? So basically, up till the elastic limit, it's still going to have an elastic nature. Limit of proportionality, up to limit of proportionality, force and extension will be directly proportional. What does directly proportional mean? That if force will double, the extension will also double. If the force will triple, the extension will also triple. But after the limit of proportionality, it is still an elastic material, but it just will not have the proportional relationship anymore. The spring will continue stretching until you get to the elastic limit. Once you exceed the elastic limit, that is when now the deformation will be permanent and it will not be able to return back to original shape and size. Okay. You can say permanent deformation or plastic deformation. Both are correct. Now, when you look under the graph, okay, you will see something interesting. What will you see? That let's say you have a spring in front of you. Okay. Now, in that spring, what is going to happen? That when you are stretching the spring, right? What are you doing? You're doing work, right? When you're stretching the spring, work is being done. Stretching or compressing doesn't matter. If you're applying a force, work is being done. Now, Hajar, there's one concept I'm going to give you that if you keep with you, a lot of the physics will become much easier. And that is this. Work done is equals to energy transfer. Remember this. I will elaborate on this more when we do the topic of work, energy, and power. But work done is equals to energy transferred. So, for example, what is gravitational potential energy? When you are lifting up an object, right? You have to do work. You are doing work against gravity, right? That's how you lift up an object. If you're lifting up an object, you have to put in some energy. Your body's own chemical energy, your body's own energy has to be utilized in lifting that object upwards. Okay. So now you are doing work. So you have to do work against gravity to lift that object upwards. The work you do against gravity gets stored as gravitational potential energy, right? If you are pushing a cart to make it move, so you have to do work. So when you do work to push the cart, it gets converted into kinetic energy and the cart will start to move, right? So work done is always equals to energy transfer. So when you stretch the spring is going to, you're doing work, you're putting energy, right? Now energy cannot be destroyed, right? So if you are putting energy on the spring to stretch it, where is it going? It is being converted into another form, and that is elastic potential energy. So in this case, you are doing work against the elastic forces, right? You're doing work against the elasticity of the spring. So when you do work as the elasticity of the spring, it gets converted into elastic potential energy of the spring. Okay. So this is stored energy. It gets stored inside the spring. Now, what will happen if you will release the spring? If you will release the spring will move back, right? Why will it move back? Because the elastic potential energy will get converted into kinetic energy. That is why the spring will move back to its original shape and size. So when we talk about elastic potential energy is the area under the graph up till the limit of proportionality. Okay, that's the important thing. Okay, so the area under the graph is equal to your elastic potential energy. And the formula that you can use for elastic potential energy is half Fe, half into force into extension. Right, Hajra, making sense? Any confusion on what you've discussed so far? Yeah, go on.
Can you just explain the elastic limit again?
Yes. Elastic limit, basically, Hajra, imagine that you're playing with a spring, okay? After the class, if you want to test it, you can even test it. Just take any spring. We have springs in your ball points as well, so you can use that if you want. So if you take a spring and you start to stretch it, okay? So initially you will notice something interesting. Initially, you will notice that the force and extension are proportional to each other. What that means is that if you will increase the force by 2 times, the extension will also increase by 2 times. If you increase the force 3 times, the extension will also increase 3 times. If you increase the force 4 times, the extension will also go up to 4 times. And you keep on repeating that. Eventually, you will reach a point after which they will no longer be proportional to each other. So for example, you increase the force 5 times, but the extension did not increase 5 times. Maybe the extension only increased 4.5. Okay. So that is the limit of proportionality, right? The point up till which the force and extension are directly proportional. So imagine that you are stretching the spring. So you double the force, the extension doubled. Triple the force, extension also increased by 3 times. You increase the force 4 times, the extension also increased 4 times. So this is directly proportional. Then you increase the extension 5 times, but the extension, sorry, you increase the force 5 times, but the extension only increased by 4.5. So now you have crossed the limit of proportionality. Okay, now you're after the limit of proportionality. The material is no longer proportional, the force and extension. But the material still returns back to its original shape and size. Then you increase the force 6 times, right? So maybe the extension only increases 5 times. But again, it comes back to original shape and size. Then you increase the force 7 times. But this time, the material, it extends and it does not come back to the same shape and size. So at that point, it is now permanently deformed. So the point after which you see permanent deformation, the point after which this material will stop behaving elastically and now the spring is completely deformed, that is the elastic limit. Okay, so elastic limit is that point after which you will stretch the spring, but instead of returning back to original shape and size, it will be permanently deformed. So it will not come back to original shape and size. Okay, that is what the elastic limit is. Clear now? Do you want me to go over it again?
No, it's clear.
Okay. So this Hajra is the first portion of our topic, which is related to your forces, right? Hooke's law. The second portion of the topic is related to your liquids, in which you have to go over our pressure. Some of the topic of pressure, Hajra, I've already gone over with you in your class, where if you remember, I went over Boyle's law and Charles' law with you, right? In thermal physics.
Yeah.
So yeah, that portion of pressure we have already done. So now we have to look at pressure in liquids basically. But before we look at that, I just want to do a few questions related to Hooke's law on you. So with you, just give me a minute. Let me share the screen with you. Hold on.
Yeah. Okay.
Okay, Hajra, the first question says, describe an experiment to determine the spring constant of the spring. State the apparatus you need, details of how to take the measurements, and how to calculate the spring constant. If you want, you can even draw a label diagram. And this is for 4 marks. Okay. So take as much the formula you know. So you already know that you will measure the force and the extension and then use the formula. So you will have to change the force. And for every force, you will have to calculate the extension and then get the formula, use the formula. So go ahead, type out the answer for this. If you want to draw a diagram, and I usually advise drawing a diagram for experimental type questions like these, you can WhatsApp it to me.
Okay. So is it going to be like the same diagram that we just discussed?
Yes, the same diagram.
Okay. I just have a question.
Sorry, Haja, what did you say?
I had a question. I was
Yeah.
drawing the graph.
Yeah.
Um, so no, I was drawing the diagram. So
Yeah.
L1 is going to be the original length of the spring, right?
Yes.
And then
Yes.
L2 is going to be
New
the
length of the spring. Yeah.
okay.
All right, Haja, I got your answer. Let me go over it. Hold on. Okay, Haja, small correction. It would be better if you take multiple measurements. Okay. So first thing is first that how are you going to apply the force? To apply the force, you will have to use a mass, right? That you've written. So now, when you've talked about your measurements, so you want to take multiple measurements of force and multiple measurements of your extension. Okay, so like change the force. First, use, for example, 10 newtons, 20 newtons, 30 newtons, 40 newtons. So use different masses, and for every mass, you measure the extension. Okay, then you plot a graph, and then you calculate the gradient of the graph. Okay, so the gradient of the graph is going to be equal to your spring constant. Remember that. Okay, because gradient of the graph is going to be force over extension, right? Y over x. So you'll get a graph. So that, and the gradient of the graph will be equal to the spring constant. Okay, you can't just rely on multiple one value. So keep on increasing the force, and for every force, note down the extension, and then plot a graph, and the gradient of the graph will be the answer. Okay, making sense?
Yeah, so if I do that and for my answer, will
Yeah,
I write like you like put different
yeah.
mass and
You,
then
yeah,
you
measure the
subtract all
extension.
of the you
Yes.
subtract
So
all of them by the
all of
original
them.
value.
Yes, all of them are. So
Okay.
you don't have to give that much detail. You've mentioned in once, right? That is fine. You've mentioned the subtraction part once. That's okay.
Yeah.
So
Okay.
then you will just say that change the value of the mass, and for every mass record the extension. So you've already
Okay.
explained how to calculate the extension. You don't have to explain it again and again. Just say record the extension, and then plot a graph, and the gradient of the graph will be your spring constant.
Yeah. Okay.
All right. Take a look at this question.
For this question, can I just say that is the maximum force which extension is directly proportional to the load?
Yes, the point up to which force and extension are directly proportional. That's fine. Okay, now take a look at part 3.
For extension of spring Q, I got my answer as 15
One
centimeters.
second. One second. One second. What did you say, Haja? What did you get for Q?
I got Q as 15
Yeah, 15 okay, centimeter. And what about R?
centimeters. Uh, I got R as 109 centimeters.
Yeah, that's fine. Okay, let me share another question. One second. Okay, so the unstretched length of this each spring is 25 centimeter. State and explain which spring would be more suitable for the baby bouncer. If you want to see the diagram, this is the diagram. So from the hook to the floor, it's 140 centimeter, and then the baby is like 100 centimeter.
I think spring Q would be better for the BB bouncer because um spring R has an extension of 110, like 109, sorry.
Yeah. So the unextension length is 25 centimeter, right? That's what they said. So 25, you do 25 plus 109, and then you do 25 plus, what did you get for the first one? 15, right?
Yeah,
So yes, what did you say? Spring Q will be better one?
yeah,
Yes, that's fine. So you will say that for R, the extension is too big, so Q is better. Perfect. Okay. All right, Haja, we'll go ahead and stop it over here for today.